Hello and welcome to this review of Java. Let me tell you first of all what my expectations are for this video segment. I'm not going to teach Java from the beginning. We're going to go back to the beginning and review. So this isn't the place to learn Java if you're in an introductory Java class. If you're in one of my more advanced Java classes, this is the right place to be. Okay, let's go back to the very beginning. You're going to be using Eclipse, and this isn't an option. You're not be using JGrasp or NetBeans or any of these other ones. We're going to use Eclipse. Here's where you get Eclipse, eclipse.org. You should get the most current version of Eclipse that is called Eclipse IDE for Java developers. This has a Java compiler built into it. You don't need to do anything else. Just go and get the appropriate one for you. You have to know if your machine is a 32-bit machine or a 64-bit machine. Hopefully you know that, and hopefully you know if you're using a Macintosh. If you are, then there's a different version of Eclipse. Everybody should be using the most current version of Eclipse. And if you're going to work on a team, so if you're going to share a code and work on a team, then it's important that you put your Eclipse in the same place. Okay, so here is the C drive on this machine. When you unpack Eclipse, put it on the C drive. Don't put Eclipse in someplace that's a very, very long path. Eventually something will break because your path to a file is too long. So do it the easy way on yourself. Don't make it complicated. And if you have lots of different ones, so you can see that I have an Eclipse with no identifier on it. Now I have an Indigo SR2 and a Juno all on here at the same time. It's really better if you only use one at a time. And it's essential that you only have one open at a time. So if you have two different Eclipses open at the same time, you're asking for trouble. They will be confused. If you're working with other people, use the same version of Eclipse as you pass stuff back and forth to each other. You don't want to have to start from the beginning every time. So use the same version of Eclipse. And if you're starting out a class now, get the most recent version of Eclipse. As of this date, it's Juno. In your semester, it might be something newer. It might be the H1 or the HIJ. These are in order. It was Helios, Indigo, Juno. There'll be a K and an L. So the most current one identified by the first letter of the name of the version of Eclipse. Okay, so I'm in Eclipse Juno right now, and I'm going to make a new Java project. I'm just going to call it Review. And in the source folder, I'm right-clicking and I'm going to say Make a New Class. I'm going to add the main method to it because I'm too lazy to type it. So here is Review Stuff. Not a very good name for a class, is it? Let's go back to the very beginning of Java. Even if you are a good Java programmer, there is stuff in here that you don't know. I will wager $1. There is stuff in here you don't know. So the very beginning, the lowest of the primitive parts of the language. Let's start there. There are 8 primitive data types: byte, short, int, long. Those are the integer data types. Please don't declare a variable L. No one will work with you. An L, a capital I, float, double. Those are the two floating point data types if your numeric value requires a decimal point. There are two more primitive data types, Boolean and char. So there is a declaration of each of one of each of the 8 primitive data types. This one takes 1 byte of storage. How many bytes in a byte? Well, there is 1 byte in a byte. And if you can remember that, then there are 1, 2, 4, and 8. So the values that can fit in these are dependent on how much space you have, so you have to know that there is 1, 2, 4, and 8 bytes of space available. In a float, there is 4 bytes of space available, and in a double, there is 8 bytes of space available. In a char, this is different from the C language, there are 2 bytes of space available. People don't talk about how much space a Boolean takes, but we can say that a Boolean takes 1 byte of space. And people don't talk about it because there isn't an issue of how big is the Boolean you can put in there. A Boolean is either true or false, and it can be stored in 1 bit, but we don't have access to a bit. You have to know the order of these. So byte short, int long, float, double is the promotion order of the primitive data types, and you must know the order because when you use mixed type expressions, there's going to be automatic promotions, and you have to know what gets promoted to what. So here's something that one of my students once made up. Beef stew is like food and drink. There are the first letter of each of those 6 data types in this little rhyming thing. It doesn't rhyme. I forget what this is called when you make up something for your memory. Let's see. So those are the 8 primitive data types in Java. There aren't going to be any more. That's all there are. And notice that every keyword in Java is all lowercase letters. That's true throughout the language. So public, static, void, these are keywords in the language, public, class, and the names of the primitives. Main is not a keyword in the language, it's an identifier. This is an identifier that we made up. String is not a primitive in the language, it's the name of a class. It starts with a capital letter. This is an identifier. It can be anything you want it to be. It's your identifier. The data type is not yours. You have to use an array of strings there, but the name of the parameter on the main is up to you. Okay. So the primitive data types, let's look now at the literal constants in the language. So these variables that I declared with very poor names have a data type. So B is of data type byte, F is of data type float, and so on. That's kind of obvious. But it's less obvious that everything in Java has a data type. Almost everything. So if you write a literal constant in the language, 1, 2, 3, 4, a literal constant is a value that isn't a variable, it's a value that you write in the code. All of them have a data type. If it's a number without a decimal point, then its data type is an int. If it is a number without a decimal point, but it's bigger than what would fit in an int, then you must put a suffix on here that indicates that it's a long. So this is a long literal constant. It ends in an L. If you put a lowercase l there, it will work, but no one will work with you. So an uppercase L. So there's an int literal constant and a long literal constant. Let's look at a byte literal constant. Sorry, we have one called b. A byte literal constant. It looks very much like an int. And in fact it is, but because it's a constant, Java can tell if it will fit in a byte. 127 will fit in a byte, so it takes this int constant and narrows it from 4 bytes of space to 1 byte of space. This is the only place in the language where a narrowing will happen for you. That's key. This is the only place in the language where a narrowing or a downcast will happen for you. In all other cases, a narrowing has to be explicit. So why can it do this? It can do this because it's a literal constant and it knows that 128 will not fit. Cannot convert from int to byte, but with 127 it can convert from int to byte because 127 will fit in 1 byte and 128 will not. And that's because a byte is a signed. All of the numeric data types in Java are signed. That means one of the bits is used as the sign bit. So in a byte, we can store the values minus 128 through positive 127. And that is the range of 2 to the power of 7 minus 2 to the power of 7 through 2 to the power of 7 minus 1. Each of these, the range of values that can store in them is calculated in the same way. If you have 63 data bits in a long, 8 8s are 64, and 1 sign bit means you have 63 data bits, minus 2 to the power of 63 through 2 to the power of 63 minus 1. I don't know what those are when you multiply them out, but I know that that is exactly the largest value that can go in a long variable. If I had a calculator and I needed to know, I could pretty soon find the answer. Let's go back to our literal constant discussions. Here's a short variable. The same thing happens as with the byte. Let's see. I wonder if I can remember this. 32,565 will fit. No, I've done something wrong here. I was trying to remember exactly the largest value that could fit in 15 bits of space. 2 to the power of 15. Well, if it's too big, it will not narrow, cannot convert from int to short, and because it's a literal constant, it knows, so there's an exercise for the reader. Find out exactly what the largest value is that will fit in a short, and it is 2 to the power of 15 minus 1. I just don't know what that is right now. So those are literal constants of the integer type. Let's look at literal constants in floating point. So here's 2.5 and it doesn't compile. So a number with a decimal point in it is a double, and you cannot convert a double to a float. It will not downcast for you. So a literal constant that fits in 4 bytes of space, that is a floating point number, has an F at the end of it. So there's a float literal constant. And here is what we just did before, a double literal constant. This one is easy. There are 2 literal constants that are of type Boolean. You write them in all lowercase letters, true and false. And to write a literal constant, whoops, we have a character variable. There is a literal constant character inside of single quotes, just one of them or it won't compile. You cannot put more than one character inside of a literal constant. A few special ones. In an integer literal constant, you can put a hex number 0, 1, 3. Okay, if your literal integer constant starts with a 0, this is not the number decimal 13. This is an octal number, base 8. So that's one group of 8 and 3 groups of 1. And if we print out this value, we will print out 11, not 13. Let's make sure that things are running here. Okay, so there it is. The number is 11. So a leading 0, it's not an O. A leading 0 means that it's an octal number. Why doesn't this compile? Well, this message is not as helpful as most of them are. An 8 is not a valid digit in an octal number. There is no digit 8 in an octal number. There is a 7. That is not the number 17. Here's another one. 0x A04. Okay, so this is an integer literal constant, an int literal constant, and it is a hex number. So the prefix 0x means that this is a hex literal constant. What is A04? I don't know. 2564. So a hex number, the ones place, the 16s place, the 256's place. So that's 10 256's plus 4. 10 256's is 2560 plus 4 is 2564. So you can represent int constants as hex or octal numbers. In Java 7, you can write a binary constant. This is new in Java 7. And you can tell if you are using, if you're using Java 7, if this compiles. So 0b is a prefix for a binary number. So 1001, what is that? 9, I think. Okay, so that is an int. Its data type is int. It's a literal constant, but its radix is binary. Okay, so literal constants. Let's do some in floating point. How about 1.5 e to the 6. So this is a double. This is 1.5 times 10 to the power of 6. Let's print it out. SYSO, control space, is an easy way of doing a system out print line. SYSO control space. Okay, so here's 1.5 times 10 to the power of 6. So this scientific notation is quite easy to write a literal constant. And you can use a capital E there if you want to. It doesn't matter. This can be a negative number if you want to. And this can be a negative number if you want to. Oh, and it actually prints out the, instead of putting all of the, it writes it out in scientific notation. I'm a little bit surprised by that. I didn't know that the print line would choose to do that. Interesting. So it is a floating point literal constant in scientific notation. If we put an F there, it won't compile because it's a double. So its data type is double. And how will we make it? You already know the answer to that. We'll make it a float. So this is about the most complex literal constant that there is in all of Java, because it has 2 letters in it and it can have 2 negative signs in it. Let's print out the F. Make sure that that's working. See, I said everyone would learn something from this, and I didn't know I was including myself. I didn't know that if that was a negative in the exponent, that it would print out the result in scientific notation. So I did learn something here. There it is. Right from the beginning, have great confidence that what you're doing is everything that can be done, and it is the right way of doing things in Java. Okay, we're at already 20 minutes or so of doing this, but I'm going to keep going. Let's talk about valid variable names. First of all, what is legal in a Java variable name? You can use underscores, and you can use digits. All of this is legal. You can use underscores at the beginning of a variable name. All of this is legal. You can use dollar signs. You can use dollar signs at the beginning. You can't use any other special characters. So this is compiling. This is a valid integer variable name. Well, it is a valid Java identifier, and we can assign that to some integer value. But you can guess that, yep, no one will work with you if you name your variables like this. Oh, there is one more. You can put capital letters in your identifiers. So uppercase, lowercase, underscore, dollar sign, and digits. Those are all of the characters that you can use in an identifier when you're making up your identifiers. That might be a class name, a variable name, a method name. You cannot start with a digit. It won't compile. Okay, so now that you have what you can do, here's what you should do. For a variable name, using camel case, all variables in Java start with a lowercase letter. This is the convention. Correctly spelled English words. Separated not by underscores, but by capital letters. So that's camel case. And I expect everyone to do this all the time. So correctly spelled English words. If you make up variable names and no one can figure out what they might be used for, that's a bad thing. Don't do it. Correctly spelled English words in camel case. If you have a constant, that means because it's modified by final, this is not a variable. It cannot be changed. Use all uppercase, and for readability, the underscore. So this is the format for a variable, and this is the format for a constant. You might be wondering, why do they allow dollar signs if they then tell you don't ever use one? There are times when Java itself has to make up an identifier at runtime. You probably don't know exactly when, but if it has to make up an identifier at runtime, it will put a dollar sign in the identifier that it creates. And there can be no identifier by that name already, or you would have a runtime error. So we have now the requirement that the dollar sign is a valid character in an identifier, but you as the programmer don't ever use one. So a couple more things about choosing your identifiers in Java. The name of a class and the name of an interface always start with a capital letter, always. The name of a method in Java always starts with a lowercase letter. So the rules for naming a method are pretty much the same as the rules for naming a variable. A method name has a verb in it almost all the time. Main doesn't, but I would hope that almost every method does something. And what it does should be the verb in the method name. It should only do one thing. That makes it easier to pick the verb. If you create a method that does 8 things, then it's hard to pick the name for that method. Okay, so what have we done in this video? Every possible literal constant in the primitive data types, all of the primitive data types, the naming conventions, the legalities of naming, and the conventions of naming, including the declaration and naming of a constant. Okay, that's enough for this one. Let's go and do another review with all of the details of the primitive control structures in Java.